Alright, so some more rules for logarithms today, you guys. I want to remind you of some exponent rules, though, before we get started, okay? So can you guys tell me what a squared times a to the 5th would be? A to the 7th. So here's the thing that just happened here. When you multiplied numbers with the same base, what did you do with the powers? You added them. Can anybody look at this box over here of rules and tell me that there's one that looks just like that, but in logarithmic form instead? Does anybody see a rule that looks just like that? The fourth one. 1, 2, 3, 4. It says right here, if you have a logarithm of two numbers multiplied together, you separate them and you add them instead. Do you see that same rule that just happened there? These are the same rules that we use for exponents, because a logarithm is just another way to do an exponent. So let's see if we can do another one. You guys see if you remember what happens when you have this rule. If you have a to the -1, what do you do with it? You flip it around. It's 1 over a. Is there a rule that looks like that in my box? Number 3, right there. Are you guys seeing that these rules are exactly the same as what we already know? Okay, help me circle this one around to see our rule. This one says what? A to the first power equals 1. Do we agree with that? A to the first power, I'm sorry, I wrote that wrong. Equals a, right? I left my, yeah. No, I just wrote it wrong. A to the first power equals a. I just wrote it wrong. Is that true? A to the first power equals a? Yeah, we've always known that rule. Okay? This one, if I circle it around, what does it say? Have we always known that rule? Yeah, do you see how these rules are exactly the same? Are you getting my point on that? Okay. So I'm just reminding you, if it's negative, it goes to the bottom of the fraction. If you're multiplying it, you're adding logarithms. If you're dividing it, you're subtracting logarithms. This one says if you have a power. Now, this is probably the only rule that's a little bit different. If you have a power on your x, you're going to bring it down in front as a coefficient. Okay, I'm going to show you what we're going to do with that in just a minute. And then there's this one that says if you have the negative out in front, you would do 1 over y for that. It's like the inverse function of that. So we're going to just do this part right here in a minute, but those are the rules. I just wanted to take a minute and show you that they're no different than the rules that we've already learned for exponents, okay? This is a new rule, though. This is called the change of base formula. And this change of base formula says that I can do any kind of a base on my calculator if I use the change of base formula. Now, if you remember on your calculators the other day, there's only the log, the log, and the natural log, the ln. And then I told you you couldn't do it if it was like log base 3, because you didn't know how to do it yet, right? You'd had to just find the power that would make it true. Well, today this rule right here shows you how to punch it in on any calculator. So, for instance, if I have log base a of b, I'm going to do the log of b over the log of a. So let me show you what that might look like. Say I have log base 7 of 12. I cannot punch that in my calculator the way it is, right? Because I don't have a base 7 logarithm on my calculator. But if I use this log formula, the change of base formula, then I can punch it in my calculator. So it says to do log of the big number. What's my big number? 12. Over the log of the small number. Now can I punch that in my calculator? Yeah, like a fraction with logarithms, it works out super nice. So I grab my calculator. I'm going to turn it on because I always forget to do that. I'm going to hit my fraction key and I'm going to do the log of 12. And on the bottom, I'm going to do the log of 7. And I'm going to hit enter and I get 1.27. So what this says is if I raise 7 to the 1.27 power, I get the number 12 for my answer. So this change of base formula is going to help us do a lot of our math on the calculator without having to do any crazy hard work. Go ahead.
I feel like all this log talk makes me feel like I'm Jay.
Okay, so we're going to show you some examples of this again in just a minute. Now, just so that you know, not only could I just use the log, the log, if I wanted to do the natural log of both numbers, I could do that instead also, okay? All right, so down here, what we're going to do today is we're going to expand, meaning going from the small side to the big side. Now, I want you to notice right here the 9 and the x are multiplied together. So do you see when they were multiplied together, I rewrote them as two separate logs with addition in between. So this is going to be log of 9, then what? Plus log of x. So do you see how all I did was I found which formula I needed to do and I expanded it back out using that formula. You following me on that? Okay, number 2 then, same thing here. We're going to expand this out. I have 1, 2, 3 parts to this. So how many logs should I be writing? 3. My first one is going to be the log of 6 plus. Okay, now do you remember the new rule that said if you had a power, where is it at? If you had a power on the number you were taking the log of, the power comes down in front. So instead of the log of x squared, I would have 2 log of x plus, because it's multiplied again, 3 log of y. Do you guys agree with that? Nice job, you guys. This is really just an exercise today, almost in rewriting from one form to the other. Does that kind of make sense? Okay, so help me rewrite this one. This is the natural log. It doesn't matter. I'm just going to expand it out using the natural log. So division. How does division get written? It gets written as subtraction. Okay, so write it out for me. What is it? Yep.
Minus the natural log of x.
That's perfect. The natural log of 5 minus the natural log of x. And we're done. Okay. Next one. I have the natural log of x to the negative 3. What's going to happen with that negative 3?
Negative 3, natural log of x.
Yeah, that's pretty simple, right? If you remember your power rules, it really is a great reminder of just how to do these logarithms.
So how would you put that in a calculator so it's like expand and solve?
You can't when it has an x in it, put it in your calculator unless you're going to graph it. Okay, we're going the opposite direction now. Now instead of writing it as 2 logarithms, I'm going to come up here and I'm going to condense it into 1 logarithm. So where the addition is, I'm going to, so it will be 4 times 5. But I know what 4 times 5 is. So I could rewrite this as the log of 20. Does that make sense to everybody how I did that?
Yeah.
Okay. I have plus and I have subtract. So the plus means multiply. The subtract means, okay, so write it out for me. Only 1 log. So what goes up on the top?
X plus 3.
X, 3.
Can I write it as 3x instead of x3? Is that okay with everybody?
No.
Yeah. And on the bottom?
4.
4. Okay. So we condensed it to 1 logarithm using the rule. Same thing, different problem. A couple more things going on. Subtraction means division, right? And numbers in front means
Upper
power. So what do I have? I have the log of
X to X.
4.
good
Over.
over
X. 4. 4 to the 7.
good.
Is that a negative 7 now? Oh wait, no.
Because subtraction means divide. We took care of the subtraction already. Okay? Questions on how I did that?
No.
I think you're getting it. I'm glad that you're figuring it out. Okay, natural log of a times b minus 3 ln of x. We're going condensed. This really could have been expanded further, right? Because this could have been the ln of a plus the ln of b. But it's not expanded further, so we're just going to condense it even more. So the a and the b, they're going to be on the top together. And then on the subtraction, it will be divide. But what goes on the bottom?
X to the third.
X to the third. Okay. Questions on that? Okay. Next problem then. This says change the base. So we're going to solve this by using that change of base formula. That change of base formula said the log of the big number over the log of the little number. Okay. So when I rewrite this, it will be the log of 12 over the log of 8. It becomes calculator work from there. Punch it in your calculator as a fraction. You have the log of 12 divided by the log of 8. And when you do that, you get, give me 2 decimal points rounded.
1.9.
1.19.
Yep.
And then the next one, change your base formula. So what's it going to be?
Log of 2, 3.
243 over the log.
Okay, punch it in your calculator. It's easiest to use that fraction key. And what'd you get?
5.
So this is interesting to see. I want to just circle this one around to show you why that worked out so nice. If I was circling this around, I would have 3 to some number equals 243. 3 to the 5th power equals 243. That totally worked, didn't it? Okay.